Welcome folks to lesson 2. In lesson 1, we looked at thin lenses. It was an introduction where we looked at the definition and the types. Today, we are going to learn about properties. So this is lesson 2 on lenses. So, properties of lenses. Okay? We have to look at optical center, center of curvature, principal axis, principal focus, and focal length. What do we mean by these? These are properties of lenses. That any lens you talk about must have what we call optical center. It must have what we call center of curvature. It must have principal axis. It must have principal focus and focal length. So anytime you talk of a lens, these are contained in a lens. A lens exhibits these properties. So let us go to property number 1. What do we mean by optical center? So optical center is a geometric center of a lens which is usually shown using a black dot in ray diagrams. A ray traveling through this optical center passes through in a straight line. So I've shown you one type of a lens. This is a convex lens. I told you in the definition, pieces of glass. In conclusion, I said it can be also pieces of plastic. So what I want you to get, the pieces, that idea comes. This figure is symmetrical along this vertical line here. This is a line of symmetry. So I want you to pick it that you can have two pieces together. The word pieces should be enhanced when you draw a vertical line here. Okay? So those two pieces put together. You can also try to think of two circles. Okay? With that line, you can consider it to be a segment, so that you have this side, a chord. You can think of a line here as a chord. So you have this one here, one segment, and another one segment. So this is geometric center of a lens. Geometric center of a lens. Okay? The geometric center of a lens is found by the line of intersection. The point of intersection of lines draw at various points. If I draw a line here and I go straight, another one here I come straight, another one here I go straight, you get a geometrical center. Okay? So it is a center of that lens geometrically. Okay? Now, let us look at center of curvature. There is a curve. There is a curve. See? There's another curve. there is a curve on both sides, this side and that side. So I've just tried to show you one possible circle in your understanding. I want you to complete this so that you have that idea which I talked of, a chord. If you draw a chord, from one point straight down, then that becomes a chord of this circle. When you have a chord, you have minor segment and major segment. So think of two minor segments put together. Now we are addressing geometric center of the circle. That's why I've drawn this circle. Is a geometric center of the circle. Okay? Of which the lens surface is part. Okay? So is a geometric center of a circle of which the lens surface is part. So you are looking at the curves, the two curves that you have. When you complete them, they form two circles. I didn't draw the second circle, but it would come here, folks. It would come here like that. Okay? It would be that. Now, lenses have two surfaces. And therefore, it means, from geometric point of view, there are two centers of curvature. Okay? Two circles have two centers. Okay? They are not concentric circles. If you have concentric circles, you have one center geometrically. So you have two circles and two centers. So you can denote one as C and the other one as C prime. But let us pick it step by step. Use keyword surface. Okay? This shaded lens has two surfaces, curved surfaces, one, and here two. So each curve complete its circle. Whenever you have a circle, you have a center, and that is what we call center of curvature. Let us look at principal axis. There is a mistake here. This is PLE, principal axis. There is a mistake here, okay? It is not PAL, PLE. It should be PLE. Please note that. This is an imaginary line which passes through the optical center at right angles to the lens. What I want you to understand is, I didn't draw that line, keep on drawing it here. Okay? There is a line here which gives you the sense of at right angles. There's a line there, okay, which gives you a sense of right angles. So it is an imaginary line which passes through the optical center. I hope you still remember what is optical center. Okay? Optical center is that. Okay? So, it is an imaginary line which passes through the optical center. Okay. We can move on to principal focus. This is correct. Okay, this is correct spelling now. This is a point through which all rays traveling parallel to the principal axis pass after refraction through the lens. So there are three key things, okay, that rays that are parallel. They pass through the lens and converge or appear to have converged. Converge, appear, disappear. Okay? So again, we can look at it from both sides, but let us continue with one side for us not to confuse. So F is used to denote the principal focus. It is capital F, folks. It is not small f. It is capital F. So rays parallel, even if it does not matter the way they come. The key thing is they have to be parallel. So even if they came from this side, if they came from this side and here, at an angle here and here, so long as these two rays are parallel, after passing through the lens, they will converge somewhere. For clarity, we start with things like this. But in testing, we are not confined to the way we started. That's why you are supposed to understand concept, not just diagram as drawn. One aspect of testing is application of concept to new scenario. Application of concept to new scenario. So what is the concept? That the rays that are parallel, whatever comes to this lens or that, so long as the incoming rays are parallel, after they have gone through, they will converge at a point known as principal focus, denoted by capital F. So you can draw another line also, because I've given you one. I want you to draw another one and see if you understand this. Okay? And lastly, focal length. This is the distance between the optical center and the principal focus. Optical center and principal focus. I've shown the optical center. Optical center, remember, is a geometric center of a lens. Now here I have given you a final idea which will give you some backup on what we had talked about at right angles. Remember here, principal axis, imaginary line which passes through the optical center at right angle. So here you get both of them because this is my final property. So I can afford to summarize all the ideas here. You can see this line. This line, if you take it from mathematical point of view, is a chord. And therefore this side is a segment and this side is a segment. This is an imaginary line that passes through the optical center at 90. So the idea of 90 can come clear here. Even this can come clear here. So the distance between the optical center and the principal focus is called focal length, denoted by small f. There is a relationship which you can prove that 2f is equal to 2 is equal to small r. where small r is the radius of curvature. Small f is focal length. So capital F is a point, but small f is a length. That is our end of our lesson, folks. Keep on subscribing. Tell your friend to also subscribe, not just to watch. Subscribe so that you get notification anytime we upload. Till then, bye-bye.